Voyager is sending back terrifying data to Earth. The Voyager 1, NASA's farthest traveled spacecraft, is still traveling across undiscovered regions of the cosmos nearly 50 years after its launch. Scientists are baffled by the scary data that this famous space probe machine is sending back to Earth due to what appears to be a malfunction. Join us as we talk about the odd data that the Voyager has been transmitting back to Earth during its source space exploration journey. Scientists have been interested in learning more about the realms beyond since the Big Bang, and that is what inspired the launch of the Voyager 1 and Voyager 2 among other space missions. The Voyager 2 was actually the first spacecraft to launch, departing from the NASA Kennedy Space Center on August 21, 1977. On September 5 of that same year, Voyager 1 was launched 2 weeks later. However, how did they switch places as twins? The weight of both probes is 720 kilos, approximately the same as a small car. Both were launched during a window of unique out-of-planet alignments that causes a slingshot effect to launch the spacecraft from one planet to another. They have, however, had to move at various speeds and on various trajectories. On December 15, 1977, Voyager 1 was able to pass its identical twin because of this, and since then, it has been our go-to resource for learning about various facts and space-related riddles. The first spacecraft to do so was this one, when it began its Jovian imaging mission in 1978. It was around 265 million kilometers from our planet, and sent a massive amount of photographs back to us. The Voyager 1 completed an outstanding 100-hour stint beginning in January 1979, during which it captured 3,750 images of Jupiter's rotation to produce a time-lapse movie showing 10 of the planet's spins. It had passed through the Jovian moon system in February 1979, and a month later, it had found the little ring surrounding Jupiter. Voyager 1 also made a unique discovery when it found 2 new moons named Phoebe and Métis. Corrective maneuvers were made to ensure that the spacecraft was ready for its flyby of Saturn, and to prevent a potential collision with Titan, one of Saturn's moons. Voyager 1 also found 4 other moons during its orbit of Saturn, including Mimas, Enceladus, Tethys, and Dione. Our scientists opted to halt the Voyager planetary mission after the Saturn mission was completed, and set both Voyager 1 and Voyager 2 outside of our solar system at a speed of 325 million miles per year. In January 1990, the new mission, officially known as the Voyager Interstellar Mission, got underway. Some of the most famous photographs in history depicting the Sun and the majority of the planets were taken by Voyager 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. They are frequently referred to as the Solar System Family Photo. There were 60 total shots taken by Voyager 1, bringing the total number of photos taken by the spacecraft to 670, despite the fact that Mercury and Mars cannot be seen in the photos for various reasons. In the end, the spacecraft's cameras were shut off to conserve power and memory before its trip to interstellar space. In addition to the interstellar probes Voyager 1 and Voyager 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Prior to Voyager 1 passing by the Pioneer 10 on February 17, 1998, the Pioneer 10 was the furthest spacecraft. Voyager 1 continued its journey for a further 14 years before it finally arrived in the interstellar environment on August 25, 2012, with no other space probes in sight to catch up with. NASA didn't publicly announce the accomplishment until 2013. Let's go to November of 2018. Both space probes have officially left the solar system when Voyager 2 crossed the heliopause and entered the interstellar medium. Voyager 1 is thought to be 145 billion miles, or 1,550 Australian dollars, from Earth. It has continued to provide us with important information that no other space probe missions have been able to divulge since it entered the undiscovered territory beyond our solar system. The spaceship has spent the majority of its 45-year trip in space in good health. However, in recent times, experts have found some odd anomalies in its performance. Voyager 1 is currently transmitting enigmatic signals back to Earth, giving the impression that it is unsure of its location coordinates. There is a scary twist to the issue, though. Normally, scientists have pre-programmed Voyager to go into safe mode or sound an alarm in the event that it becomes lost in space, but up until this point, it has not. Additionally, its antenna, which transmits data back to Earth, appears to be in great working order. However, the data it has recently been transmitting is suspicious. The Interstellar Explorer is functioning regularly, taking instructions from Earth and carrying them out, as well as collecting and transmitting scientific data. However, readouts from the probe's articulation and control system do not accurately reflect what is taking place within, according to a NASA official statement. What exactly is happening on board, then? Every spacecraft that is headed towards interstellar space, including the Voyager 1 and 2, has a special 12-inch diameter gold-plated disc that is loaded with audio and video messages as a backup in case an alien species discovers the ship. 35 Earth noises, 115 live photos, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary General Kurt Waldheim are just a few of the contents on the space DVD. Additionally, they are recorded in 55 different languages. So, if it was taken over by aliens, they would presumably be attempting to decode the signals. Thoughts that the spaceship is currently under the direction of aliens have been quickly refuted by scientists. Voyager's ability to function depends heavily on the ACT, attitude and articulation control mechanism. For starters, it always maintains its antenna aimed at Earth so that scientists can correctly receive data. Additionally, it controls how the spaceship is oriented. Engineers keeping an eye on the situation now feel that the ACS is functioning as it should, which just adds to the enigma we already face. Additionally, none of the safety features designed to shield the spacecraft from danger have been activated, according to Susan Dodd, project manager for Voyager 1 and 2. A mystery like this is par for the course at this point in the Voyager mission. The spacecraft are both about 45 years old, which is much older than what was envisaged in the mission plan. Dodd also acknowledges that the spacecraft's engineering crew will encounter some significant difficulties in resolving the problem with Voyager 1 because of the distance between us and the space probe. The challenges are formidable, largely due to the spacecraft being approximately 145 billion miles away from Earth. This immense distance introduces several complications that the team must navigate carefully. A rescue operation is nearly impossible, given the current technological and logistical constraints. Voyager 1 is far beyond the reach of any spacecraft or repair mission that we could feasibly send. The spacecraft's incredible journey has taken it into the outermost regions of our solar system and beyond into interstellar space, where it continues to travel further away from us each day. Messages received from Earth at the speed of light take almost 21 hours to reach Voyager 1's current location. This means that any command or instruction sent by the engineering team requires a significant amount of time to be received by the spacecraft. This delay poses a substantial challenge for real-time problem-solving and troubleshooting. Furthermore, once Voyager 1 processes the command, any response or data it sends back to Earth will take another 21 hours to return. This implies that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it exceptionally difficult to implement quick fixes or iterative troubleshooting processes, which are often necessary when dealing with complex technical issues. The engineering team must meticulously plan and execute each command, anticipating various scenarios and potential outcomes. Unlike missions closer to Earth, where engineers can swiftly send and receive commands, the long communication delay necessitates a more strategic and patient approach. Each instruction must be carefully crafted to address the known issues without causing additional problems, considering the lengthy time it will take to confirm whether the command had the desired effect. The significant communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Every command set must be effective and precise, leaving little room for error. This necessitates extensive testing and validation of commands on Earth before they are transmitted to Voyager 1. In addition to these logistical challenges, the spacecraft itself is over 4 decades old, having been launched in 1977. The technology on board, although state-of-the-art at the time, is now considered ancient by modern standards. The engineering team must work with equipment and systems that were designed and built in the 1970s, which adds another layer of complexity to the problem-solving process. The harsh environment of space also takes a toll on the spacecraft systems. Voyager 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeorites for over 45 years. These factors contribute to the wear and degradation of its components, making it even more challenging to maintain and repair. Despite these hurdles, the engineering team remains dedicated to resolving the current issues. They are exploring various hypotheses about what might be causing the anomalies, and testing potential solutions through simulations on Earth. This careful, methodical approach is essential, given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also leveraging the redundancy built into Voyager 1 systems. Like many space missions, Voyager 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems if the primary systems prove to be faulty. This capability provides an additional layer of options for addressing the current problems. Despite the difficulties, there is a sense of optimism among the mission team. The Voyager missions have a long history of overcoming challenges and continuing to deliver valuable scientific data against the odds. The dedication and ingenuity of the engineers and scientists working on the project have been critical to its success. If the team is successful in diagnosing and resolving the issue, Voyager 1 could continue its journey, providing insights into interstellar space and beyond for many more years. As the spacecraft ventures further into the unknown, it carries with it humanity's spirit of exploration and discovery, pushing the boundaries of our knowledge and inspiring future generations of scientists and engineers. This spirit of exploration is at the heart of the Voyager missions. Both Voyager 1 and Voyager 2 have provided invaluable data about our solar system and beyond, transforming our understanding of space. Voyager 1, for instance, has given us insights into the heliosphere, the bubble-like region of space dominated by the solar wind, and its interaction with the interstellar medium. By crossing into interstellar space, Voyager 1 has allowed scientists to study this boundary in unprecedented detail. One of the significant discoveries made by Voyager 1 is the detection of interstellar plasma waves. These waves provide clues about the density and composition of the space between stars. This data is crucial for understanding the broader structure of our galaxy and the forces that shape it. Additionally, Voyager 1's instruments have continued to measure cosmic rays, charged particles from outside our solar system. This information helps scientists learn more about the energetic processes occurring in the galaxy.